Hi, welcome to the Linux channel. I shot various episodes on TUN-tap interfaces and this is something quite interesting when you are doing some network appliance, especially some type of VPN device or some type of compression device, something like that. So it is not just limited to Linux alone. It is something possible with FreeBSD also. So this is why when I was discussing about this VTUN source code, I do remember mentioning about its support with respect to FreeBSD and stuff like that. So it's just not about Linux itself, but having said that, it is quite useful when you are doing especially something like that. So I do get lot of queries on TUN-tap. Whenever viewers have watched my videos, I do get some queries in the form of comments or else in the form of emails, and sometimes I do get from beginners or freshers or college students. I can give one suggestion is, if you are a student, if you are quite new to networking, TUN-tap is quite an advanced topic. Again, it is subjective. It may look simple, but it is quite an advanced stuff in terms of its real-time usage. I'm not saying it's a basic stub code or something. It looks so simple, but when it comes about real-time usage, it is quite it depends how far you want to utilize a feature like TUN-tap in your applications. I mean to say not applications like user space applications. I mean to say in your projects is what I mean to say application. So if you are a student, I suggest in case if you lack some networking know-how, network software development, I suggest you to build those skills further before you deeply venture with respect to TUN-tap or something. But in case if you are a beginner, you have some level of network software development expertise, then it is something you can dive and then explore. Having said, TUN-tap is quite often used in any such tunneling and VPN application. So one such example itself is this VTUN project, so which you can do IP tunneling via UDP, IP tunneling via TCP and stuff. So this episode, what is I'm going to do is, in the second episode I have showed a sample code where you can do a TUN-tap interface with a C code, and I have showed a quick demo of the same. So I thought let me do a bit extended version of this episode, because I do got lot of queries about TUN-tap stuff when it comes to real-time usage. So as a bonus segment, I would like to also show my toffee code in real time, how it is getting utilized. So moving on, you can see here I did some similar source code. It is little different than what I have done for episode 2. Basically it's the same, but it is quite different than what you have seen in episode 2. So I will walk through the source and I do some couple of demos so that we'll get a picture. So you can see here it is actually currently running. I was testing it before shooting this episode, so let me cancel the same and check that it is all settled down. Yeah, so now currently the interface is down. It's you can see here it's no more enabled. So let's just do freshly a demo so that you will get some idea about the same. So in the episode 2, you can see here this is my source code. I have discussed about the various aspects of how you can create that interface and stuff like that. The same thing I like to discuss in this episode, but as an add-on I would like to give an overview that in case if you are curious, I would highly recommend you to go through this standard documentation which is available within the Linux kernel source code. You can see here you can traverse documentation networking. Under that you have this tuntap.txt, and they have provided extensive documentation. If you are not aware of certain stuff like this driver file and stuff like that, you can see here you can do a search devnet TUN and then you can find it some amount of documentation about the same. In case if you are wondering, even this entire source code is a sort of the same stuff what I have picked it from the standard documentation. So it is not much different what you find here in the documentation. versus my source code with some minor changes here and there. So to suit our needs, I have done some changes here and there. Okay, so that's about it. And moreover, they have included some documentation and stuff, versus I have just done it in a different way. So this is a way you can create a TUN-tap interface via C code. And in case you don't want to use a code, then what you can do is with the standard IP commands, you can create the same. So which is why you can see here I have just included the same over here. You can use this stuff, standard IP commands, and then you can create a TUN-tap interface, and then you can do similar demo what is possible with this code as well. So this is what it is. So before doing with the standard command, we just quickly do with the code, and then we analyze the code, and then we can parse that interface, and then we do via that IP command without a C code. Okay, so we can do that, and finally I can show my Toffee code. It's a production code, and you can see that how it is different in the production code versus this so-called test or sample code. Okay, so this is what you can see. I created this API, and this API takes these two parameters. One is the name of the interface and the type of the interface. The type of the interface is, you can define whether it is TUN or tap. So that's about it. So as I said in the intro episode, the TUN is meant for a specific use, tap is meant for a specific use. You can go to Wikipedia. Apart from this documentation, you have this very good documentation in Wikipedia about TUN-tap. So you can refer that, and in the Wikipedia they have provided the clear documentation about the same. They mentioned that TUN is for routing, tap is for network bridge or layer 2 context. So this is what. So based on that application, you can choose either a TUN type interface or a tap interface. If you ask me, in my applications, I generally used as a tap interface when it comes to Toffee or something. But having said, you can use a TUN type interface for IP based tunneling and stuff. But in my situation, I have created a tap type interface, and then I have bridged the standard port, and then I can get the packets through that tap interface, and from there I can do IP level processing using the same. So it's a different approach, but without using this TUN type interface. But having said, either way you can achieve the same type of results. But this is stuff which I have to take a decision as a part of my architectural stuff. So it's just a different way I have approached, but you can get that idea. So this is what. So what is the thing is, first we can run it like a TUN or tap, doesn't matter. Either way, this particular example runs the same. So we just create the interface and we see how it is getting invoked. So what we do is, we just quickly compile this code. The code I have put inside this folder. What I do is, I do a tarball of the same, and I include this download link, so that in the video description you can get that download link of that code, and you can download and you can play around. Okay, so we can just compile the same TUN-tap create.c. Yep, it is compiled, and /TUN-tap create, we can run the same. So before that, I would like to mention that you can see here, if config -a, there is no interface existing as any no custom interface which we created with this code. You can see here, I'm naming this interface as my TUN-tap 1, because it can be set as TUN interface or tap interface, doesn't matter. So which is why I'm keeping a generic name like that. Okay, so this is what. If you are a beginner in network, software development, whenever you do if config, please note, when you do if config, sometimes it may miss some interfaces. You can see here, when you do if config, it doesn't show all the interfaces. So whenever it doesn't show those interfaces, you can assume that these are the interfaces which are not active. Okay, so these are inactive interfaces, which means there is a net device, data structure instance exists. The linked list instance exists, but since it is not active, if config command is not going to show you the same. Okay, so this is what. So which means there is an interface, let it be a physical interface or a virtual interface. There is a net device data structure instance there. Okay, which is what is this. but it is not active, so it is not going to be shown as ifconfig command. So when you do ifconfig, always you want to make sure you can double check with -a option, so that to show all the interfaces, whether they are irrespective of active interfaces or not active or inactive interfaces. So make sure yourself that you are not missing anything. So that way, if you see, when we run this code, sudo./tuntap create, okay, so we run this code, and you can see here it has been running successfully, and we come here and do an ifconfig. When you do an ifconfig, it is not going to show the same, because we have not activated that interface, we have not enabled, or we have not turned up that interface. Okay, so that's what, versus if you do ifconfig -a, then it is going to show that interface over here. So this is what, so which means the net device data structure context is created, but it is not enabled. Okay, so that's what you can do straight away ifconfig my tuntap 1 up or something like that, and if you want, you can even provide an IP address or anything like that. So here you can see, here I just commented. So when you download this code, you can just try to iterate whatever I can do, I was doing in this episode. So I just included those steps, so you can just do this. As you can see, the earlier interface name I kept it as my tap 1, so instead of better I change it to my tuntap 1. So we can do the same, sudo IP address add, we can just include any IP address. You notice this address I'm adding something which is not my subnet. Okay, so this is my subnet 0.88, versus here I'm adding it with 3.1/24 subnet. So this is what, so we can just include an IP address. So with that, when you do ifconfig -a, you can see it has got this interface address, an IPv4 address, and then you can do this sudo ifconfig my tuntap up. You can either do this way, or else you can do with IP command also. Okay, so when you do this ifconfig, you can see here with the standard ifconfig, now you can get that interface details, and then you can use like any other interface. Since this is not a physical interface, this is a virtual driver. The tuntap itself is a virtual driver, so since it's a virtual interface, it is like dangling around. Okay, so you can't connect this to anywhere unless you create some type of a bridging or routing context. Okay, otherwise it is just going to dangle around. When you type route command, you can see here it has created that route instance table entry. 192.168.3.0 is the network with subnet mask is 255 or 24 bits of that port. Okay, so this subnet is connected to this port, so that's what is that route command denotes. Okay, so we can do a standard ping of the same 3.1. it's going to work. So the interface is up. In the source code, we are doing this infinite while loop. So this is something even yesterday when I was handling a session with my student, I was discussing. Generally I do any code with this type of an approach, an infinite while loop, because this denotes a production type of network software code, because once you boot any networking appliance, it is going to run any services forever. Okay, so it's going to run forever as a backend service. Let it be a router or some network switch with Linux kernel created network switch or anything like that. So it is going to run forever. So that is why the while loop, an infinite while loop or for loop, something like this denotes it's more like a service. Okay, so that's why. So there is an infinite while loop, and it is doing this read operation, and it is going to print the number of bytes. Okay, if you are curious, you can even do some type of operation like this: struct IP header star IP equal to, you can do this buff plus 0. You can offset like this, and then you can assume that buff starts from IP header. In case if it starts from layer 2 header, Ethernet header, maybe you can offset with plus 14 bytes, or you can put some type of hash defined like eth header len or something like that. Okay, so you can do anything like that, and you can parse and do anything. So about packet parsing and network stack design, I have discussed exclusively in my video series on networking protocols. Okay, so you can just refer the same in case if you are curious about it. So in this case, let's not do that. It's just a simple read, and then we are printing how many bytes we read as a hint. Okay, so that's what is the objective. Maybe we can do some initialization like this or something like, it's just optional, so something like this. Anyway, you can see here it is printing here whatever it has received. We just did a quick ping, so I feel that is what it is getting printed over here. So this is one way we can create this interface. And if we do the code walk now, you can see this API, we have this driver getting used, the device net TUN. That's the thing which is documented over here. So if you search, you can find some documentation. You can see here, in order to use, you need to use that driver, and you need to open the same and stuff like that. So you can just refer that, and this is how you can do. And you can cross check. You can see here device net, and then if you do ls-l, you can see you have this TUN device file, and it has so and so permission. So of course you need to access this with root permission. So that's what we are doing it, and we are getting this file descriptor, and if there is any error, we are returning error. Okay, so otherwise we are doing this ifrec struct ifrec initialization like this, memset 0, and then we are setting the type. And this is where, if you check the source which they provided over here in the documentation, they have just hard coded like this. So you can have all these options. IFF TUN for TUN type interfaces, IFF tab for tab type interface. So you can choose either of that. And in this case, they have just hard coded as TUN, and that is why in the API they have not mentioned any type, whereas in my case I just mentioned as type, so that we can do either of that type. Okay, so that is what. And then rest, it is the same. Here they are calling the device name as device, versus here I am calling the device name as name itself. You can see here ** of name, so that it is more clear. Whenever I see anything as star device, I remember the kernel's net device data structure rather than a device name. So I don't want to confuse, so that is why I am using this nomenclature. So we are doing the same, and we are setting its name here for the IFR instance. So with that we can do this IO control operation. So in the IO control, we are doing this TUN set interface, and we are passing this so that it gets that name for that file descriptor. So we are passing this file descriptor. For that file descriptor, we are passing these properties. So it will be set in the Linux kernel TUNTAP device driver, the virtual device driver, and then from that moment on, we can start using that interface, something like this. So that's what is overall it is happening. And you can see my code is no different than what is being provided in the standard Linux kernel documentation source as well. So that's what. So having said, this, as you can see here, this is something, it works this way. We can just cancel and come out, and we can even set this as a tap interface. It is going to run the same, because you can set interface IP for either of that interface. So if you even create a bridge control switching interface, bridge interface, you can set an IP address. So that's the main idea behind the same. But internally, one is suited for layer 2 type of stuff, one is suited for layer 3 type of tunneling. Okay, so you can change it as a tab, and rest it is going to be the same. We can just quickly compile, and then we can run the same. And once it is running, once again it is going to vanish. You can see it is not going to exist. -a, it's not going to exist as an active interface. Okay, because it is just created, but it is not going to exist as active interface. So one more time, we need to provide these commands. So we need to do this, and we need to bring up that interface via sudo ifconfig up, and then it is going to exist as a active interface. You can see there, and we can just do the ping like done before. So either it is TUN or tap interface, it is going to work the same in this level of operation. But when it comes to actual production use, whether you are using it for some type of VPN type device or something, or IP tunneling or something, then it really matters. Okay, so this is what something I believe I have not discussed in the earlier episode. Okay, and moreover, as you can see here, the episode title itself, the episode 2, the title itself is all about sample tap interface. I have not generalized as either TUN tap interface. It is a sample tap interface within the subject of TUN tap interfaces. So that's what this episode is all about. But in this episode, I thought, let me just put together and generalize and give some context. So you can see there, it just works like before, and it gives us all this stuff. What we can do is we can just do in this way itself. So okay, so we can do without C code, even we can create an interface this way itself. So what we can do is we can just do that way and see that it works similar to what it worked earlier. So the syntax is IP TUN tap, and then you can set add to add a new interface and a device and the name of that device. So my TUN tap 1. And then you can mention its mode. So mode, you can mention it as tap, which is the layer 2 context, and then rest it is optional. As you can see, it is all within this square brackets. Okay, so with that, I think we are good to go. So we add the sudo. So it is created. If config, it's not going to show. If config -a, it is going to show, and rest it is the same. So you can just set some IP, and then you can do this. So note, setting an IP to this TUN tap is just optional. Okay, I don't do in my code. I mean, in my Toffee code, I never do any IP address setting for any TUN tap interfaces. It is just optional. Nor I do any IP address setting for any bridging interfaces also. So like if I do any BRCTL, add bridge and other stuff, I don't set any IP address for those bridge interfaces. But you can do the same. I even seen OpenWRT devices have that IP addressing set for bridging interface rather than its connected ports and stuff. So you can do that if you wish to do. Okay, so if you do now, if config, it is going to show, and we can just do the same ping operation. It's going to work just like what has been done in the C code. And to deactivate, we can just do sudo if config my TUN tap 1 down, and then we can reverse it. We have to still delete that interface which is there. You can check if config, it is not going to show, but when you do if config -a, it is going to show there, because it's just deactivated, but it is still existing in this net device kernel data structures. Okay, so we need to gracefully remove the same using this command. Once again, you can provide this del I'm sorry, not this, using this using this command, using IP TUN tap. So del device my TUN tap mode tap. So it's been removed. If you now do if config -a, you can see there it is no longer going to exist. So which is fully, it has removed it from that net device data structure linked list. Okay, node. So this is the thing. And other than that, I thought as a part of this episode, I also quickly show my code. So it is a production code. You can see how far it is going to exist. See, this is a concept, but if you're a beginner, you don't still know that how in reality this is something like this is used in a mega huge code. Okay, so let me just show my code so that you will get some quick picture. So this is my daemon part. In the daemon part, I get some type of packets via TUN tap interface. You can see here I have that tap interface. I'm opening it. I have hard-coded the name as tap interface because I don't use the TUN part of it, as I mentioned before. So you can see there, and I'm doing a read operation. This is more or less the same as what has been done over here. So it's the same. And if I go back here, you can see this tap interface is being initialized somewhere with this one of these common APIs actually. So somewhere I have provided the same. I'm not sure it is not there, it is in sockets. So this does a lot of UDP socket initialization and all. Apart from that, it also has this logic to get this tap interface up. So you can see this is my production code. It looks again similar to the code what is provided as an example. So of course it is going to look the same because there is nothing to change, because this is what it is. I mean, you need to use UDP sockets, it is going to look more or less the same thing what you get any example code. So same thing it is here also, but in this case you can see I'm passing this file descriptor, and the file descriptor is not returned. Instead I'm just returning this true or false, which is far more clear rather than this stupid example code what I have put for this YouTube video. So we don't know whether it is negative number is whether it is false or positive is true. Instead of that, in the production code I'm returning a proper true or false. And in the case of file descriptor, I'm properly putting the file descriptor only in the case if it is returning the true, and if it is returning the false or something, then I'm not setting this file descriptor. So this is what. So you can see in this case, since it is not a question of either TUN interface or tap interface, I'm hard coding this as a tap interface. I'm no longer doing anything, and so that's about it. So with this, it is created. I'm doing the same, IFR stuff, and I'm doing this TUN set interface. But again, this is a production code, highly tested and worked around. So this is not something to be confused with some sample code stuff like that. So if I want to change any one bit over here, I will think twice, okay, before doing some changes just like that. Okay, so because it's a working code, I don't want to tamper much, and at that point of doing that code, I must have done some study, and then I have taken a decision to add this extra flag. You can see here tap interface, and then I'm adding this extra flag. By now I have completely forgotten, although it is documented here, do not provide packet information. I still don't remember what is this exactly meant at this point of time. So I must have read completely about it and done some tests before doing that in my production code. So this is what it is. Quite common whenever you do such large code. Sometimes after many months, if you visit, you yourself don't know that what you have done. So this is what it is. So with this, the tap interface is initialized, and with this I can use this tap interface. You can see as a sample. In this case, we are opening this, we are reading from the tap interface, and then whatever the packet is read, it is being checked. If it is some kind of bogus v4 packet or corrupted packet, I can do the checks and then I can drop them off. And if it is not something a v4 packet, I can bypass. And if it is a v4 packet, a proper v4 packet can be optimized, I can do that further optimization by sending it to other modules via this UDP, whatever it is. So something like that, I'm doing it in my Toffee code. So this is a real production code. So this is how it looks versus any sample code. It is just a sample code. It just has that specific concept, okay, not to be confused with a production code. So hope this gives that complete big picture, because this episode I thought of not taking also, but since I get some frequent queries about other TUN-tap episodes, I thought let me do a general episode so that it kind of clarifies more questions of whatever viewers get, and I have to address the same. I have addressed in the past, but again I thought this is something they are a little confused. I thought this may a little bit clarify. So you can do like I said, you can do with the C code, or else you can write some shell scripts or some type of Python or PHP scripts, and then you can automate via standard IP command this way. Or else you can do with C code, whichever way it is possible. So if you are a network admin, you don't know much about programming in C or C++, you can very well use that standard available commands, and then you can automate through those commands itself. You can of course write some shell scripts. If that interface is up, do something. If that interface is not up, and do something. You can anyway automate that, and you can try to achieve. But of course you can't add any network stack or something upon it unless until you are a programmer. But having said, if it is meant for some minor requirements, you can well do with that command line options. You can doing it with C itself is optional. Okay, so this is what. So hope this gives some big picture. In case further, if you have any questions, feel free to be in touch via mail or YouTube comments. If you are really a beginner, if you don't still understand whatever I'm talking about, maybe the video is not meant for you. You are not yet come to that level of understanding. So put your effort and time understanding various concepts before getting yourself into some advanced stuff, because this is something just a couple of days back I got an email from a student. I'm not sure he's doing a bachelor's or master's. He's interested doing some AQM stuff in Linux kernel. So his query is about something he's struck or something like that. Just vaguely I got a 4-line email, but after reading that email I was really clueless exactly what is intended to do and where he is struck. And moreover, when you think about AQM or Codel, whatever it is, these are stuff already put and implemented in Linux kernel as it is anyway. So kernel is very mature. Its network data path is the control plane, data plane, whatever it is, it's quite mature. I'm not sure really what they want to achieve or he want to achieve in that. So as a beginner, often you get some type of, you may read something online and then you may think, let me do some project on that and stuff like that. But often you are really, either you may do something very simple which is already available, or else you are attempting to do something you are thinking it is simple but it is a quite complicated one. So most probably you are not sure about it. So this happens for students and beginners most of the time. Similarly, even something like TUN-tap, although the code looks quite simple, in fact the code looks much simpler than a typical socket code. That doesn't mean you get confused and assume that it is simple stuff. It depends. It can be leveraged using this simple TUN-tap. You can write a huge stack on top of it, and you can sell your stack for millions of dollars also. So this is what it is. So don't get confused by the size of the code or something like that, or just demo what I showed. The TUN-tap is a virtual interface which you can create in the Linux kernel. This is one type of virtual interfaces. You can create a virtual interface in multiple ways. So this is one way of creating the same, and you can define its role. Either it is meant for TUN is IP tunneling, or tap is for layer 2 type of tunnels. So you can tell that, and you can further write your entire stack using this interface to get and send your packets. So this interface is just a small part of that huge stack. So same way, if you compare the Toffee code, this is a very small part. Okay, so you can see here after this read, this is not going to end with this read operation. After that, the main thing starts in the stack. I do several steps after that, and then I need to take a decision which way I need to process that packet, and how I can architect that load sharing, and so many stuff and steps involved. So that's what a real production code is all about. So if you are a beginner, if you are not able to get certain concepts, maybe you are not prepared, you need to spend more time understanding the basics. I mean to say basics is not reading about OSI layers or something about sockets. Just not that. Okay, when you think about network software programming, you need to work on several aspects, and it takes quite some time before you attempt any deeper level stuff, something like this. So spend your time, put your efforts, try to gain that expertise. Either you can do yourself, or else you can of course join any classes either outside or under me, and then gain some experience so that you get that level of understanding, so that you can directly get into doing any sort of larger projects. Either it's a part of your bachelor's, or else some type of post graduation research or projects or whatever it is. So have that stuff in place. In college you may study about everything about computers, in case if you are a computer science student, but not necessarily they are going to focus about network system software development in that network software development. So it takes some time to get that type of flow. So take your time. In case if you have anything to discuss, be in touch via email or post your queries in YouTube comments. Thanks a lot for joining me. Stay tuned. Have a nice day. Bye bye.